Okay, in section 5, we're going to be talking about graphing linear inequalities and then systems, so multiple linear inequalities. And remember, an inequality, different from an equation because it's a less than or a greater than symbol used instead of an equal sign. So when we're looking at linear inequalities, just like we can compare two variables in an equation and get a line, with inequalities, we're going to get a line with an entire region of solutions, a complete region that works to satisfy an inequality. Most commonly, because it's an entire region, you're going to see this written graphically. It's hard to write it algebraically, so you're going to see graphic regions of solutions. And to do that, if I look at step 1 here to graph these linear inequalities in two variables, you're going to start by graphing the inequality as if it was an equation. And that's called the boundary line, where our region starts or stops. Step 2 says determine whether the boundary line will be part of the solution set. So the key here, you have two situations. Situation 1 is if the equation or the inequality contains a greater than or equals to, less than or equals to sign. If that's the case, use a solid line. The second situation is if it's just strictly greater than or less than. If that's the case, we use a dash line because that doesn't include. So dash line means doesn't include, solid line means include. Next, we must determine which side our solutions are, which side of that line. So a common way to do this is pick a point. A lot of the time that point is going to be 0, 0, because 0, 0 is really easy to work with. Plug a point in. If it's true, shade that region. If it's false, shade the opposite region of the line. Probably the easiest way to go about this is just to jump into some examples, kind of see how we can apply these to graph. So if we look at the first example, we need to graph this, and I'm going to use Desmos graphing calculator to help us out. We need to graph this as if the inequality was an equation. So let me do that first. X plus y equals 2. Some key features on this line, it crosses the x and the y axis at 2. I'm going to make those notes on my graph. So I have an intercept there and one right there. Before I draw a line in, step 2 says determine if it's part of the solution set. So we need to determine, is it solid or dashed? Well, what tells me that is this sign right here. It's a less than or equals to. That means it's going to be a solid line. So I'm going to make a solid line on my graph. And remember, because it's an inequality, it's a whole region that's going to be our answers that work for this inequality. So that's step 3. Determine what side we need to shade for our region of answers. And remember, I said to do this, we often plug in a point. So what I'm going to do is use, let me make my text a little bigger. I'm going to plug in 0, 0 to see what region to shade my solutions. So if I plug in 0, 0, x is 0 plus y is 0 is, and we need to do the less than or equal to. So I'll just do that because I'm typing 2. Use this sign up here though. I'll just use less than or equal to. Is 0 plus 0 less than or equal to 2? Yes, this is true. So what I need to do then is, since I picked the point 0, 0, this point right here, that means anything on that region is a solution. Anything on that region is a solution. So negative 4, 0 is a solution. Negative 6, negative 3 is a solution. Negative 6, 6 is a solution. But 6, 6 would not be a solution. So anything in this shaded region is a solution. And actually one way you can check is I can change this on Desmos to a less than or equal to. And that should match my graph over here. Okay, Continuing on, let's try this next example. 3x minus 4y is greater than 12. So 3x minus 4y equals 12. Let's do the line without any regions yet for step 1. So it looks like it crosses at -3 and 4. I'm going to make some points. -3 and 4. Since it's just a greater than right here, just a greater than, it's going to be a dashed or a dotted line. So I'm going to make this a dotted line. Now I need to determine which side my solutions lie on. So let's test 0, 0 again. Let's plug that in. 3 times 0 minus 4 times 0, is that greater than 12? Well, 3 times 0 is 0, minus 4 times 0, which is 0. Is that greater than 12? No, 0 is not greater than 12. So that means our solutions don't lie here at 0, 0. They lie on the other side. I'm going to shade this side, the side that is not 0, 0 in it. This whole region is our solutions. We can double check that on here. I'm going to change that equals to a greater than, dotted line. Anything less than that is a solution. All these points in green are solutions. Okay, let's look at this last one. Y is less than or equal to -4. Again, step 1 says let's look at it as though it was an equation. And you probably already know this is a horizontal line crossing the y-axis at -4. So we know it crosses at -4. Oh, let me keep that black colored. It's less than or equal to solid line. And then what region? Well, we can test 0, 0 to see. Now when we test 0, 0 in this case, something you can maybe read. When we test 0, 0, we only need the y value. There's no x value. So it's 0 less than or equal to -4. No, 0 is greater than -4. So that means 0, 0 is not in the solution set. All these points down here below the line are, I gotta grab the right tool here. This is the first time I've used this Kami app. Still getting used to it. There we go. All of these, and we can double check that on Desmos. Less than or equal to. There we go. Okay, last one here. X is greater than 5. So we know if x equals 5, it's going to be a vertical line crossing here at 5. Because it's strictly greater than, we're going to make it dotted. And then what side is our solutions on? Well, again, if I test 0, 0, is 0 greater than 5? No. That means all our solutions must lie on the other side, which would be the right side of the line, the side that doesn't include 0, 0. And I can double check that over here. There we go. It matches. So that's graphing one inequality. We know with a system, we need to look at multiple inequalities. So if I think about a solution to a system, the solution lies where the two regions intersect. So the solution to a system lies where the two regions intersect.